morning, students. Once again, I will continue with solving problems from 2018 EE paper. The problem is the voltage VT. This is voltage VT across the terminals A and B, as seen in figure, is a sinusoidal voltage having a frequency omega equal to 100 radians per second. 100 radians per second. When the inductor current IT, this is the inductor current, when the inductor current IC is in phase with the voltage, the magnitude of the impedance Z, that means you have to look into the terminals, the impedance Z seen between terminals A and B is dash. Now clearly this is a problem on resonance. So resonance is the topic. Now what happens in the case of resonance? When the impedance and its imaginary part becomes zero, then the voltage will be in phase with the current. That is the condition for resonance. So the imaginary part, having found the impedance Z, if you equate the imaginary part to zero, then it results in resonance. Now in this circuit, we have to find the impedance first. So L value is not given, so it is also not required. C and R values are given. First we shall find out impedance. So R 100 ohms. What about XC? XC is 1 over omega C, that is 1 over 100 into 100 microfarad. 100 microfarad, that is 100 ohms. That is 100 ohms. Therefore, it is represented as minus J100. Minus J100 ohms. Now, first I will find the impedance of this part. Now, these two are in parallel. When they are in parallel, components are in parallel, admittances can be directly added. Therefore, admittance of this plus admittance of this is equal to admittance of this part. Now I will find impedance of this parallel circuit. So admittance of the parallel circuit. Yp is equal to 1 by minus J100 plus 1 by 100. 1 by 100. This is admittance of this parallel combination. Now I will multiply and the numerator and denominator by J minus J100 into J plus 1 by 100. That is J squared is minus 1, minus of minus plus 1. Therefore, it is J by 100. J by 100 plus 1 by 100. Therefore, 1 by 100 into J plus 1. 1 by 100 into J plus 1. Now, I will write the impedance for this parallel circuit. The impedance for this parallel circuit is reciprocal of this. That is 100 by J plus 1. 100 by J plus 1 ohms. Now, the impedance of this can be added with the impedance of this. That gives you total impedance Z. Total impedance Z equals J omega L plus 100 by J plus 1. 100 by J plus 1. Now I will take the LCM. J square omega L plus J omega L plus 100 equals J squared is minus 1. Therefore, minus omega L plus 100 plus 100 plus 100 plus 100 J squared minus 1 minus omega L plus 100 plus J omega L by j plus 1. Now I will, because there is in the denominator there is j plus 1, I will rationalize. Rationalizing this, we get multiplying numerator and denominator by j minus 1. J plus 1, j minus 1, or sorry, it is 1 plus j, 1 plus j, it is 1 plus j, sorry. I will write as 1 plus j, rationalizing 1 minus j, 1 minus j equals 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 a plus b into a minus b, a squared minus b squared minus b squared, j squared is plus 1 plus 1. So that is 1 plus 1, 2. Now multiplying minus omega L plus 100 plus j omega L, next minus into minus plus j omega L minus j 100 next minus in minus j squared is minus 1 plus omega L cancels. Next 100 plus j 2 omega L minus 100 divided by 2, that is 50 plus half 2 omega L minus 100. Now at resonance, this part becomes 0. So when this part becomes 0, imaginary part becomes 0, what is left over? 50. Therefore, what is impedance? The impedance of the circuit as seen between the terminals is 50 ohms. So this is the answer, is 50 ohms. So what is left over is only real part. Imaginary part becomes 0. Thank you.